You might think, oh, well, if you want to keep your kids from being anxious, you should just protect them from bad things. A metaphor that I'd like to use is if you're a gardener, you can't dictate how every plant is going to come out. And you wouldn't want that. What you want to do is create a context where many, many different kinds of plants can thrive.
Hi, I'm Elizabeth Koch. We all live inside our own personal, private perception box, built by our genes and the physical, social, and cultural environment in which we were born and raised. In this podcast, we explore how, although the walls of this mental box are always present, they can expand in states like awe, wonder, and curiosity, or contract in response to anxiety, fear, and anger. I'd like to introduce our esteemed hosts, two incredible and distinguished minds. Dr. Heather Berlin, professor of psychiatry and neuroscience at the Icahn School of Medicine at Mount Sinai in New York City, and Dr. Christoph Koch, chief scientist for the Tiny Blue Dot Foundation and the current meritorious investigator and former president of the Allen Institute for Brain Science. Welcome to the Science of Perception Box.
Hi, everybody. Welcome to Science of Perception Box. I'm your co-host, Dr. Heather Berlin.
And I'm Dr. Christoph Koch.
So every week, we feature an aspect of Science of Perception Box, highlighting the latest research together with our expert guests. And this week, we're exploring the world through the lens of children, including the often overlooked strategies and tactics that young children use to decode the world around them. And I cannot imagine a more groundbreaking and qualified researcher to explore this topic with on the show than Alison Gopnik. Alison Gopnik is a world-renowned expert in child development, a psychologist, and a philosopher. She's authored several popular books, including The Scientist in the Crib, The Philosophical Baby, and The Gardener and the Carpenter. She's the winner of the 2021 Carl Sagan Prize for Science Popularization. She's also a professor at the University of California at Berkeley, and her research explores how young children come to know about the world around them. Her work is informed by the theory, which is the idea that children develop and change intuitive theories of the world in much the same way that scientists like us do. So first, we want to open up with our own connection to adolescence and parenting. So, Christoph, you're a father. Has raising children changed how you think or about your perception box?
Well, I guess you see viscerally in your kids how their mind is constructed and how their perception box, whether it's narrow or broadly, is learned by them. But then you're also astounded. I mean, you point out certain things, you tell them what's important in life and in culture and what's not so important. And so they learn your biases partly, right? But then you're also astounded when 10 or 20 years later, they tell you, oh, I thought this was, I remember I watched many times with my daughter this movie, Alice in Wonderland, the original Walt Disney, really a wonderful movie. And I thought, Gabi, I thought you loved it. And then she said, no, you did.
I remember, actually, my father said to me when I was growing up, he's like, I've already forgotten what you haven't even learned yet. No, that stuck with me. But on that note, anyway, let's welcome Alison to the
So pleased to be here.
podcast. We're so excited for you to be here. So let's just start with the basics. How do children learn?
Well, that's a good question. One thing we know is that children are designed to learn. That's the whole point of childhood. So the reason why we have this very long period of immaturity when we can't do anything that's very useful in the world is exactly because that gives us an opportunity to learn. And if you look across many, many species of animals, you see this interesting relationship between how long a period of childhood a species has and how much they rely on learning, roughly what we somewhat anthropocentrically would say how smart they are. But roughly speaking, how large their brains are, how much they can learn about new environments, that's all connected with that long period of childhood. And most of that learning actually seems to happen in that early period, in that period of childhood. And we're starting to understand how children do it. They do a lot of the same things that scientists do. They pay attention to statistics, which might seem a bit surprising. If you ask them about, what is P.05, they won't understand what you're saying. But if you give them statistical data, you will give them a bunch of sounds or a bunch of events that have a particular statistical pattern, they'll pick out that pattern right away. One of the things that we've studied now for the last 30 years is how children make causal conclusions, because understanding the causal structure of the world is really important. So here's a simple example. You give the child our extremely inexpensive piece of equipment compared to you neuroscientists. Our equivalent of the fMRI is a little box that costs, $49.99. It's a little box that lights up and plays music when you put some things on it, but not others. We call it our Blicket detector. So here's what happens. 24-month-old, still a baby. You put a red block on the machine and it activates 4 out of 6 times. Now you put a blue block on the machine and it activates 4 out of 18 times. Now you say to the baby, can you make it go? Now for both of them, they've seen that it worked 4 times. But if they were doing the statistics, if they were doing the probability, they'd say, oh no, this one is more likely to make it go than that one. And that's exactly what they did. And that's just one example where even this is 24-month-olds who are just starting to walk and talk are making these kinds of statistical inferences. The other thing that they do is that they do experiments, except that when 24-month-olds do experiments, we call it getting into everything. So if you watch the way that a 2-year-old is just completely driven at, sometimes at the cost of their survival, to go out into the world and make things happen and see what will happen next. It turns out that when you look carefully, it isn't just that they're kind of behaving randomly. They're actually doing exactly the things that they need to do to find out the most about the world around them.
But this is all, do you think this is happening unconsciously? I mean, they're born natural statisticians to navigate the world, but this is all unconscious mechanisms that are occurring.
It's a good question, and it's one of the ones that I've thought about. We don't have very systematic evidence about this, but here's my view. My hypothesis is I think they're quite conscious of their conclusions. So if you ask them, by the time they can talk, a 3-year-olds will tell you all about, this is what happened, the block went on, this is the reason why it works, this is how it works. But they're not at all good at tracking the evidence that led them to believe that. So if you ask them about the red and blue blocks, they'll say something like, well, okay, the red one always made it go and the blue one never made it go, even when they're trying to do the statistics. So they're very good at, I think they're very conscious of their contents of their minds, what they think is true, what they believe. I think that's true even with infants. But they're not very good at tracking why they thought that or where it came from. And that's true, of course, for adults as well.
But do you think they're actually building in their mind a model of causality, that this thing makes that thing happen?
Exactly. And we've actually shown that. So part of the inspiration for this was that we started out collaborating with people in the philosophy of science and computer science. We're trying to design computers that could do causal inference. That would obviously be a really important thing to do. It's a big piece of current AI, is could you get a system that could figure out causality? And what we found was that the representations that those computer scientists were talking about turn out to be the best way of describing what the kids are thinking, what's going on in the kids' minds. So they really do have little theories, right? Little networks of here's one variable and here's another variable and here's how they're connected. And that can even be pretty complicated, 4 or 5 different variables with different kinds of
So that seems to support the idea, which is very much in resonance with perception box thinking, that causality is constructed by the mind. It's not just given at birth, right? But it's something we infer, or our mind infers about the world.
Yeah. I think the way that a lot of philosophers, including me, would think about this is there are all sorts of things that are happening out in the world. And when we say that it's causal, what we mean is if we did something to the cause, it would have an effect. And that makes it different from just prediction, for example, or just association. There's something more abstract about thinking that there's really a causal relationship there. But there could be lots and lots of different, I'm not sure that from a God's eye view, that you'd look down and say, okay, these are the causal relationships and these aren't. But from a practical point of view, it's really
given
important.
by our experience, right? So it's really David Hume. It's given by our experience of causality. When I said, oh, that made that thing happen.
Right.
It's based on my exposure early on in childhood of these events where I learned to associate that A always precedes B.
Well, except that there's a catch to that, which is that's true. But it's also true that once you know about causal structure, one of the things that means is that you can build a rocket that goes to the moon that has never occurred in history before, right? So that suggests the fact that you can have the causal relationship and then you can make things happen. James Woodward, who's the great philosopher who has talked about this, his book is called Making Things Happen. So the thing about causal inference, even though you have to go from your experience and you're never sure that you're right and you could always be wrong, is that it lets you go out and make things happen in the world. And that suggests that you're really tracking something that's real about the world. And kids very much want to track the things that are real.
So, how does that change in adulthood? I mean, theoretically, we're always learning. The brain is always wanting to learn about new information and make causal inferences and whatnot. So are there any things that children are better at doing than adults? And what are they not as good at doing?
So there's a very helpful distinction that comes up in computer science. Also is nicely alliterative between exploitation and exploration. And the idea is this: suppose you're trying to solve some problem, right? Well, one thing you can do is you can kind of get a good enough solution so that you can actually go out and implement it and get the thing that you want. That's the exploitation kind of attitude. Another thing you could do is you could just try a million different things and see whether any of them work or don't work, what the outcomes are going to be. And that's exploration. And it turns out that you can show mathematically that you can't get a system that will simultaneously give you the best exploitation and the best exploration. But you just think about it intuitively. And again, I think thinking about the difference between kids and adults is a good way of describing this. Your 3-year-old is going to be very good at learning new things, very bad at getting to his snowsuit on so that he can get to preschool in the morning. And part of the reason why he's really bad at getting his new snowsuit on and getting to preschool is because he keeps saying, "What's that? There's a little tiny dust thing on the carpet. And look, there's a airplane that just went on high." And my favorite example is my 3-year-old grandson. He thinks the most awesome thing in the world is the garbage truck, right? And of course, if you think about it, he's right. Like, garbage men take these giant things and throw them into the back of the garbage truck, and then it turns around. So, his attitude is, why do you want me to get my snowsuit on when I could be watching this amazing thing, the garbage truck, right?
But it's the curiosity too. Like, I know, like I'm trying to walk my son to school. He's 7 and we're late. And I'm like, come on, let's just go. We got to go. I have this goal in mind. And he's like, oh, look, the daffodil, and he's like going to pick the flowers and look at the things on the trees. And part of me, it breaks me because I want him to be exploring and excited about things. But then I'm like, okay, we have,
But does this also mean that your son or your grandson experiences the world in a different way because they are constantly, they may not even have, I think as some of the earlier research has shown, like this focus of attention, that they see this vast blossoming field of stuff happening and they're constantly distracted by it?
Yeah, so the metaphor that I've used is when you talk about the kind of adult exploit attention and consciousness, it's like a spotlight, right? So that's an old idea, is consciousness is like a spotlight. Everything else that you're not paying attention to kind of goes dark, and then you just have this brightly lit spotlight. And what I've argued is for kids, it's more like a lantern. It's like everything is equally illuminated. And there's some beautiful new neuroscience work, which actually shows that the children are representing more of the world, representing more of a stimulus than adults are when you give them the same problem. What they did in these experiments was they set up a situation where you could either pay attention, I have to remember the details, you could either pay attention to, say, the color or shape of a stimulus, for example, right? And what happens is, for grown-ups, if you say, I want you to track the color of this, then you'll track the color and you'll just forget about the shape, right? If you do the same kind of experiment with children, they're not as good at just remembering the color. But then at the end, if you say, all right, now I'm going to give you kind of a trick question, what were the shapes that you saw? The grown-ups will have forgotten that because they weren't paying attention, but the children will have remembered it. And it turns out that if you look at shape versus movement, so you look at whether you're encoding the shape that something is or what direction it moved in, different parts of the brain are encoding shape and encoding movement. So now suppose you show someone something where there's a movement in the background and a shape in the foreground, and you say, I want you to pay attention to the movement, or I want you to pay attention to the shape. It turns out that if you do that, grown-ups will pay attention to the thing you said, and then they won't encode any information about the other thing. So if you ask them at the end, well, what was the shape? They won't tell you what the shape is. Children, on the other hand, seem to be understanding something even about the things that they weren't paying attention to. And now if you look at their brain decoding, you can see that both the shape and motion parts of the brain are encoding the information.
I think it's a sort of cost and a benefit because, like the prefrontal cortex isn't fully developed, until like around mid-20s. And that is what helps us focus the attention and suppress out extraneous information. So I think that, it's an advantage and a disadvantage, and it's a disadvantage and they're not as good at being focused but they are taking in much more information and there could be some advantages of that. And I think a lot of adults are working very hard to try to turn down their prefrontal cortex so they can get back to that basic childlike curiosity and playfulness, right? And there's a joy in that. So do you think that adults should be aiming to get more like children, sort of defocus of attention, letting go of prefrontal cortex activation, taking it all in? Or, whose has the advantage and the disadvantage here?
Yeah, I think, again, what comes out of the computer science is it's a trade-off. It's just one of those intrinsic trade-offs. There isn't a clear advantage. And what you want systems that can do both. And interestingly, the solution that computer scientists, completely independent of not knowing anything about kids, come to is start out exploring. Start out with what they call a high temperature search. Start out doing things that are kind of noisy and random and all over the place. And then gradually go into exploit mode. And the human brain seems to be kind of like that, which starts out with this enormous scope of potential neural connections that you could have. And then as you get older, the ones that you use a lot get to be myelinated, they're more efficient, and then you lose a lot of other potential. And again, I don't think it's an advantage of one versus the other. It's a trade-off. And, you wouldn't want a 3-year-old to be the head of your department or the president of your university, right? There's lots of reasons why there's a reason why everyone always celebrates the
executive control. Yes.
Yeah, it has to do with the way we raise and the way we live in society, right? If we need people that can focus for 8 hours a day just on this one thing, then we need to train kids early on. I've seen the difference. So my grandson, Ulysses, he first went to kindergarten in Singapore, where it's all about sitting down, focusing, and ultimately trying to take tests. While he's now in Norway, where it's much more, explore this buzzing confusion that is life. And I think it just maximizes for different goals, to your point.
But I think to get back to Heather's point about adults, I don't think adults ever can get themselves back to the state that's as open-ended as a 3-year-old. As long as we've been human, adults have done things that give them a kind of break from the responsibilities of executive function. So, staying up all night, having a retreat, having a religious ritual, having a time and a place where you say, all right, now I'm not going to be worried about those everyday things that I have to do just for,
it's
weekend.
The letting go and
right.
but or even just, I think sometimes spending time with children and seeing the world through their eyes. Like I know when I'm with my children, it just forces me to be so present and immediate, and you can almost like see the world through them and get back a little bit into that childlike state. I think the key is maybe turning the knob up or down.
Well, I think it's interesting because when you see what are the sort of things that adults do that seem to have that effect, they're things that put you in a functional state that's more like a child. So traveling, for example, is an example that I've given where, when you're in a new place, you're sort of forced into the childhood state. And this speaks to the perception box point because one thing that we've looked at in our work, this also gets back to the point about how are they doing these causal inferences, is the thought that there's something like a kind of Bayesian inference process that's going on. And we've shown that even very young children are doing something like Bayesian inference. So Bayesian inference is that if you have a lot of evidence for something, right? If you have a really good reason to believe that something is true, it should take a lot to get you to budge you from that belief. If you've done something and you get lots and lots of reason to believe that this is true, then you should hang on to that, right? You should have, that's what Bayesians call your prior. You should pay attention to your prior. And a lot of what we do as grown-ups is saying, right, I've learned a lot. I know how the world works. Now I'm going to take everything that I know already, and I'm going to put it to use to try and solve this problem, let's say. But if you're a child, and even, independently of all the special brain characteristics of children, if you don't know as much, then almost automatically you're going to be more open to learning. That just kind of makes sense. So doing something like going to a new place where you don't know exactly how everything works. Or an example that I like is when you look at a lot of artists who have late styles, a lot of times what artists will do, consciously or not, is kind of disrupt the thing that they've been skilled at. So Matisse, who's a great painter, says, no, I'm going to do cutouts, right? Something that he's never done before, that he doesn't actually have any skill about.
They purposefully try to put their brain back into the state where they're forced to learn.
Yeah, I think that's the idea. I've become so skilled at painting that I can't get to new places in my painting. Let me try something that I've never done before. Let me try something that's going to be awkward to begin with. And I think those are all examples of the kinds of things that grown-ups can do that put them back. But I agree with you, Heather. I mean, one of the things that I think makes being a parent, being a caregiver, so profound is that on the one hand, it's like the most responsible adult thing that we ever do, taking care of other people. But on the other hand, it means that you can be in a state of, at least vicariously, of seeing what the world looks like from the eyes of a child. And I think you're right. I mean, my own personal view is that I do my meditation by taking care of my grandchildren, and I'll schedule in, okay, I want 3 hours with my 6-month-old, grandniece once a week, because that's when I get out of being in my own head and I'm in the world in which garbage trucks are the most awesome thing that you could imagine.
Yeah, it's like you enter their mindset. But I think it's the concept of novelty. And when you're young, everything is new and everything is exciting. And then there is this sort of cynicism as you age of, I've been there, done that. But if you can keep the novelty, and then what you're saying about changing skill sets is that creativity, it's dopamine, really. It's like keep the dopamine. So if you paint the same way every day, day after day after day, there's nothing stimulating about that anymore. Mm-hmm. And I think that's what keeps people young is the curiosity, the novelty, then the creativity. So, and that's very childlike. Mm-hmm. So I think that's as a tip to adults is to do something different, do something novel, walk a different route to work.
Which in a way is a way of making yourself into a child again, right?
Yes.
Because you're purposely, it's like evolution is handicapping the children, right? Evolution has designed it so that the children aren't terribly capable and have to learn everything. And of course, that's not true for all species. So if you look at chicks, for example, there's lots of animals that are mature really, really quickly. And there's a beautiful study by a biologist named Emily Snell-Rood, who's even with insects, if you compare butterflies that learn how to decide which, these are cabbage white butterflies. So they have to decide which kind of vegetables in my garden are you going to destroy, right? And some of them, it turns out, just have reflexes. They see something that's green and then they munch on it. But there's others that actually will flit around from leaf to leaf and sample them and decide, okay, this is the one that has the best outcome. And then they'll go and eat that leaf. Now, all of these butterflies are living this very short time, but the ones who are learning live longer and have fewer eggs.
That's why I think it's a link to
longevity
in some ways. The brain can atrophy just like any other sort of organ, and there's a stimulating factor to it of learning new things, the novelty, and it is getting back to a youthful type mindset. But speaking of this concept of perception box, isn't childhood a time when our perception boxes are forming, right? And do we end up then getting once it's formed, stuck inside a particular, perception box, or is there still opportunities to change?
Well, one thing that we found consistently is if most of the time, if you give younger kids a task and older kids and adults a task, the grown-ups will do better because they're better at executive function. But we found that there's a very characteristic kind of task where children actually do better. And that's if the solution is unexpected or novel or not the obvious solution. And that gets back to this Bayesian point about it's not your prior. Say we give children one of our obligate problems, and the solution's not an obvious one. Would be weird for a machine to work this way. And then we show a bunch of data that says, yeah, the machine's working in this weird way, both to adults and children. Adults just stick to the thing that they thought when they came into the experiment, and children will change their minds. And interestingly, what we found is that for a physical thing like the boxes, then 4-year-olds are the most flexible. And then when you hit school age around 6 or 7, you become a bit less flexible. And then in adolescence, you really start looking like an adult. But if we give the kids a social problem, a problem about why did someone do something? Why was he not willing to go on the trampoline in the schoolyard? Then what you see is the 4-year-olds are the most flexible. They're the best at thinking of lots of different reasons why that could be. They get less flexible in school age. But then the adolescents, the teenagers, are the most flexible of all. So in a social context, the teenagers are most likely to think of something that's new or unexpected.
So how would that be explained by Bayesian priors? Because you would expect those priors over time just to become progressively
exactly
in its final form.
So that's why I think part of it is just what you know. So as you know more, you see less. But I think part of it is actually what your brain is doing. And there's some evidence that in adolescence, the parts of your brain that are involved in social cognition and understanding are sort of re-energized. They're reorganizing. They're becoming more plastic again. And that kind of fits your intuition that it's this adolescents, the teenagers, who are the cutting edge of social innovation and social creativity and social change. I think the 3 and 4-year-olds, a lot of the time, and they're thinking about social things, but a lot of time they're thinking about, like, how does this world around me work?
I remember having hung out with magician at the Magic Castle in LA. Many magicians dislike performing
That's right.
in front of young children because the young child is sort of likely to point out, Dad,
exactly.
what's he doing with his hand behind his back?
Yeah, I've always loved that. And I've had the same reaction from magicians. I had a lovely, when my book came out, I had a lovely letter from a store detective. And he said, look, what I do is I stand, it's fully visible. I'm standing up on the balcony looking down to try and see if anyone's pickpocketing. And he said, and none of the grown-ups see me, but the children I'll have the children waving up, sort of making contact because they are aware, they're open to the possibility that there's someone standing up high. And I think it's the same point as the magicians.
They're attending to these different things. I mean, and you've written about that parenting, as we know it, is kind of like a new concept, the way that we parent. Can you explain some of that? Are there these preconceived notions in Western society about how we parent or raise children, and are they incorrect?
So one of the things that I've been working on recently is caregiving. So this evolutionary trick of having a childhood where you can explore, that depends on having a grown-up who's actually keeping you alive and taking care of you in that period. And it's something that's very characteristic and very deep about us humans, that we care so much. We care for children, we care for elders, we care for the ill. And yet it's something that psychology kind of has, and not to mention politics and economics, never paid much attention to. What's the special thing that you do when you care for someone, or particularly when you take care of children?
This is above and beyond the role of parents? You mean grandparents? Or
caregivers in general. And we know that one of the things that's really distinctive about humans is that we have a much wider range of people taking care of children than, say, even chimpanzees do. So for chimps, it's mostly the biological mother who's doing most of the caregiving. But as long as humans have been around, we've had what the anthropologist Sarah Hrdy calls allo mothers. We've had a whole, this is the old slogan about it takes the village. And we have my favorite adaptation, which is that we actually have postmenopausal grandmothers, which is very unusual and sort of evolutionarily paradoxical. Why am I here? I haven't been fertile
You've
for 20
served your
years,
purpose.
right?
Why
I
are you
should
sticking
think I would be
around?
gone. And there's a lot of evidence that it's actually having that wide range of caregivers that enables the children to learn as much as they do. And it's not just that they're being taken care of, but also that those elders are passing on all the information from their past experience. So that very distinctive cultural characteristic of human intelligence seems to come from those grandmothers. The grandfathers aren't quite as paradoxical as the grandmothers, but so you might think, all right, I have to do this thing. I'm taking care of this child. If you've got that 35-year-old exploit mindset, right, where you say, okay, well, what do I do when I go to work? What do I do when I go to school? How do I accomplish something? You might think about that caregiving as, oh, okay, here's a set of goals that I want to accomplish. I want this child to come out a particular way. And now I'm going to find the skills I need to accomplish those goals, because that's mostly what we do when we're adults. But if you think about it a bit, caregiving for anyone isn't like that. It's not about, well, I'm caring for someone because I want them to have certain kinds of, properties come out a particular way. An example that I like to give is, we don't wive our husbands. It's not like we sort of say, well, yeah, I think I'm doing a pretty good job because my husband is definitely, showing better skills than he was when I married him. And, he's definitely getting better, right? In fact, if anything, it's kind of the opposite, right? It's when you say, oh, look, he needs me even more than he did when we got married. That's when love and care really.
So is it about compassion?
Exactly. So I think if you actually get more descriptions of what the intelligence of care is like, often in religious contexts, than you do in economics, for example, right? So in economics and politics, you think, I do something for you, you do something for me. But caring for someone isn't like that. And being with someone who needs us, right? It's one of the things that comes out of the happiness literature. Is that
It gives you purpose.
Exactly.
And, that's why I think a lot of the parents are, what do I do when my kids go? Like, what is my purpose? It's such a greater purpose for some people. But also, evolutionarily speaking, well, first of all, babies evolved to be really cute, so we'd want to take care of them. They have all these, features that make us, big eyes and all of that. But those who were more caring were more likely to have their children survive. And, so there is some sort of evolutionary aspect to that is innate within us.
And I think there's a good argument. Again, Sarah Hrdy has made this argument that a lot of our very distinctive human capacities for things like cooperation and our ability to have a really complicated social network. Again, the typical way of thinking about that is, oh, it's like a contract. I do this for you and you do this for me. But that's not what it's like. It's about, I'm in a community or a family and I care about you, so I'm going to help you to do what you want. Not because I think you're going to reciprocate sometimes, but a lot of times it's just caritas, right? That seems to be very...
And it's also paving the way to allow children to become who they're meant to be. They're,
right.
allowing them to develop.
And it even extends beyond our species, right? People care for their companion animals.
That's right.
And that sort of seems a very sweet and innocent love, because it's not driven by any profit, right? My dog or my cat that's 15 years old, where I have to inject every second day because of kidney issues, right? She's not going to give me anything except just...
the satisfaction of caring.
You do get some things like so my kids
you get
love back. They're very, cook and then like, you didn't make the pasta. I wanted the, this kind of pasta, not that kind of pasta. Like, oh, okay, sorry. They can be very demanding. However, there are those moments of pure love and affection in return. Not that you're doing it for that, but it is a nice.
And I think in terms of our evolutionary history, this is a point that people have made. For most times and places, children have had much more opportunity to explore and much less of this kind of, the kind of contemporary investment parenting, middle class American attitude towards being a parent is really unusual, both culturally and historically. And for most of history, what we've done is both provide this context of sort of safety and nurturance and capacity to not worry about what's going to happen to you in the next second, and then a capacity to go out very broadly and explore, and for whole groups of children to go out very broadly and explore at a much younger age than we probably would. Then I think people
But that doesn't
do
happen
that.
today anymore.
And it's increasingly not happening. And I think it's not good for children or for the culture or the society at large.
That children should have more time to free play and have unstructured time and develop in the way, as the scientists that they are.
Unsupervised. Is that what you mean?
That's right.
Unsupervised?
Yeah.
But that's very difficult to conceive of today. Oh my God, my kid's unsupervised since 1 hour. What are they doing?
Well, there's a marvelous result that's one of my favorite results in psychology. So the oldest result in all of psychology, going back to good old J.B. Watson and behaviorism, is put the rat in a maze and it goes down one arm and nothing happens, and then it goes down the other arm and it gets shocked. And it will never go down the arm where the shock was. That's reinforcement learning. It's the basis of modern AI. It's the basis of psychology. But of course, if you think about it, in some ways, that's a really smart thing to do. But if you think from this exploit, explore contrast, it's not such a smart thing to do. Because if you never go down that arm of the maze, you're never going to find out that maybe sometimes there's cheese at that end. Maybe the shock only comes once every 50 trials. And in fact, that's a model for anxiety disorders. What happens in anxiety disorders is you avoid doing the thing that will have the negative outcome. And then you never learn that actually you're more competent than you thought and the world is less scary than you thought. All right. Here's the beautiful result. That is true for adult rats. So now what you do is you have the juvenile rat and you put the juvenile rat in the maze. And the juvenile rat would prefer to go down the arm where there's the shock.
This reminds me as a teenager.
Exactly.
This is who I was
and
as a
it's
teenager.
funny because it's, like with rats, they mature pretty quickly. So it's a little hard to tell what exactly is
what age
they are. But there's some there. It's not the newborns, but it's somewhere in between there.
So why?
But here's the catch.
Yeah.
Okay. You might think, why? Right?
Yeah.
This seems so bizarre. They'll only do it if the mother is present. So if they can smell the mother, then that's a signal that says, all right, find out, explore. Even if you get shocked, it's worth it to get the information.
So that's if you would say, they have a healthy attachment.
Exactly.
With the mother and they feel safe enough that they can explore a dangerous area.
Yeah.
Getting into...
So what implication, if any, does it have for modern childhood?
So the thought is that what you need in childhood is not to have a mother who's saying, don't go there, you might be a shock. What you need is a mother who's just there. And we started doing some work showing that children actually think this, that just here's a background, here's a context where you're going to be safe, bad things are not going to happen to you. And that's just the fact that here's a mom or a caregiver, a grandmother, a father, an uncle.
It's like a safety, a source of safety that allows you to have this exploratory,
there's
behavior.
This kind of beautiful, I think there's this beautiful sort of complementarity between this capacity we have for care, this capacity we have to say, look, you can do something. I'm going to make sure that it's all right in the long run. And then this capacity we have as children for exploration. It's that capacity that we have as grownups for care, which is not, I'm going to shape you. I'm going to figure out what you're going to do. I'm going to make you grow up in a particular way. That's the thing that really is enabling the children to explore. And that's the thing that's ultimately enabling human progress.
So today we're confronted by this pandemic, or the rise, particularly in the young, of generalized anxiety, right? Do you think that relates maybe partly to this new, more protective, oh my God, I always have to watch my kids every minute style of parenting?
I think it's very hard to actually do the empirical work. We know that various kinds of psychopathology go in these, it's epidemiology. They go in these cycles where they go up and they go down and no one ever can figure out exactly why. But it certainly seems plausible theoretically, and other people have argued for this, that if you don't have a chance to explore, you kind of would predict from what we know about the mind and the brain that anxiety would be a consequence of that. And I think it's kind of interesting because it's sort of counterintuitive. Like you might think, oh, well, if you want to keep your kids from being anxious, you should just protect them from bad things. But it turns out that actually letting your child take risks, letting your child explore, letting your child see, okay, here's here's this terrible thing that happened, but I've figured out how to cope with it. Here I am.
It's also, it's helping them build resilience. It's just like this book, The Calling of the American Mind, which is exactly saying that. It's like you have to allow kids to have some adversity, almost like to inoculate them and to teach them how to overcome and be resilient. But it's the balance, right? You don't want to be overly, permissive where it's dangerous, right? Just there's no supervision, their kids are, getting hurt and not learning. But then too much over control can lead to, anxiety where kids just feel like the world is a very unsafe place. So I think it's parents today are put in this position of like, what is the right balance between safety and protection and allowing for exploration and growth and some resilience, right? Not everybody gets a trophy. Like sometimes you don't get a trophy and that's okay. You have to learn how to like work through those feelings. And that creates healthiher adults over time.
I mean, I think it's all about trade-offs, and it's tricky about how you actually manage this trade-off of a metaphor that I'd like to use is it's like being a gardener, right? If you're a gardener, what you do is you can't dictate how every plant is going to come out. And you wouldn't want that, right? Because you want your garden to thrive even when the weather changes, even when things are different, when conditions are different. But what you want to do is create a context, create a place where many, many different kinds of plants can thrive, and they can thrive in different kinds of ways. And that's my picture of what caregiving, at least for young children, should be about. It's that sense of possibility. There's a technical term in AI that I like called empowerment. And what you do in empowerment, that sounds kind of touchy-feely, but it's a very technical computer science form of reinforcement learning, is you want your agents to be able to control as much of the environment as they can in as many different ways. So you
need to expose your kids to all sorts of different environments.
Exactly.
And learn how to deal with them.
So I think this is sort of like a psychological version of what happens with the immune system, the same way that it turns out that having to physically, your immune system facing potential viruses makes you deal with them better. I think the same thing is true psychologically.
I want to get a little into AI because you've talked a little bit about comparing how children learn to the way AI models learn. Can you talk a little bit about that?
Yeah. So that's what I've been doing versions of this for 20 years, but especially in the last 5 or 6 years, because the new AI systems depend so heavily on learning, people in AI have gotten more and more interested in development. But I think the summary is that even these really powerful AI systems that depend a lot on just getting lots and lots of information and having lots of computational power can't do things that even very little children are very good at doing. So if you look at our little Blicket detector experiments, the AIs, like the large language models, are very good at summarizing, here's what everybody knows about the fact that a glass will break if you drop it. But in our experiments, we're showing children causal relationships that they've never seen before and no one has ever seen before, because we're making them up for purposes of our experiment. So if you give the system something that no one's ever seen before, nobody's ever posted anything about it on the internet, nobody's ever talked about it in a YouTube video, they're not very good, as you might imagine, at figuring them out. And even the little children are very good at figuring out new things. People in AI talk a lot about out of distribution, things that are not the things that you were trained on, or being able to have, this is a phrase I really like, is the non-stationary environment. The non-stationary environment means what happens when things change, right? What happens when the world is different from the world that you were trained on? And the amazing thing about these contemporary AI methods is they can get trained on enormous amounts of data. But what happens when now you're in a different universe, now a different world than the world that generated all that data in the first place? And kids seem to be really good at dealing with that.
Okay, so at the end of every episode, we ask a perception box question that we all answer. So my question I have is, what's a memory that you keep returning to and why?
Well, I had a kind of nice event about this with a memory recently where my grandson is, I'm now experiencing having grandchildren going through adolescence, which is a whole other experience. And I suddenly had a memory of when I was 13, being in my room at the top of the house that we lived in Philadelphia, and being a terrible insomniac, and being up at 2 a.m. and running down to the garden and just having this sense that everything was so intense and so amazing and so wonderful and so scary all at the same time. I mean, it was like a kind of psychedelic experience, but it was just being 13 and awake at 2 a.m. and walking out into a rather grubby little garden in a rather grubby part of West Philadelphia had that kind of, felt as if it had that kind of significance. And I could see with my grandson, oh yeah, that's what's going on here. I can see some of that.
I love that. And Christoph?
Well, at roughly the same age, my father gave me for good scholastic performance a telescope. I was at the time in Morocco. And I remember, because my older brother and I, we computed where the position of the planet Uranus in the sky, and I pointed the telescope at it, and there this blue beach is drifted into view. It was just, talking about awe. I had this feeling of awe, the feeling down the scalp in your spinal cord, because there's this incredible degree of order and regularity. That's why I'm a scientist.
And I love that. And I love it. Sort of, I'm thinking about perception box, like how, what Alison was talking about was how the same experience, walking in the garden, could be so different for you depending on different places you are in life, different brain states that you're in. Whereas in one time, it's just a boring garden. And at another point in your life, it's the most, exciting experience, just having to do with the lens with which we see it through, right? So my memory, I must be like, I'm going to say maybe 6 or 7 years old, and I'm in my grandmother's kitchen, and it's like a cold winter day, and she's serving me like the Campbell's chicken noodle soup out of the can. She would just dump it in the pan and heat it up and give it to me. And she just sat with me, and I'm eating my, Campbell's chicken noodle soup. And I just had the feeling of safety and security and warmth and like happiness. Like there was no place I'd rather be than in her kitchen eating that chicken noodle soup. I'm getting emotional. But that memory is something, it's just a place I go back to as like a safe place. So on that note, thank you for being here. It's been wonderful.
Awesome.
If you'd like to learn more about your own perception box, spend some time this week answering the same perception box questions that we asked our guests, and check out other questions on the website, unlikelycollaborators.com. You can also subscribe to our YouTube channel and watch the show or listen wherever you get your podcasts. This has been Science of Perception Box, created by Unlikely Collaborators in partnership with Pod People. I'm Dr. Heather Berlin.
And I'm Dr. Christoph Koch. Thank you very much.